There. The pulley must not touch the post frame. If it touch, it cannot rotate. Okay. Number two, connect two weights of 20 grams each by means of a light string that passes over the frictionless pulley that is mounted on the force frame. Make the distance between two weights about 100 centimeter from the foot of the frame. So I have explained earlier that these two bodies, okay, two weights of 20 grams. Okay. Do you see the weights? Nakikita nyo ba? Pau?
Yes po, sir. Kita po.
Okay. They are both 20 grams, so they are balanced. There. Because if one of the mass is greater, it will go down. So they are balanced, both 20 grams. Okay. So the distance is approximately 100 centimeters. And this is 95, okay? Uh, Procedure 3. Add 5 grams to 10 grams weight of one of the masses attached to the string, making it heavier than the other mass. Determine the time it would take the body to descend to the force of the frame. Repeat this several times to get the average time. Okay. So the procedure says we have to add 5 grams to 10 grams of one of the masses. Since we have two trials, the first trial will be additional 5 grams. So I have here 5 grams. This is 25 centavo coin. Okay. So we have to add on the one of the masses. Okay. We need the scotch tape. Ano ba yun? Okay. I have to use scotch tape to add this 5 grams. Okay. So one of the masses, one of the mass here now is added 5 grams. So what will happen if a weight is added? It will go down like this. Okay. The heavier mass will go down. There. Okay. So what we'll do now is to determine, to get the time, the heavier mass descended or went down. So, Paula, are you ready?
Yes, sir. Ready po.
Okay. If I say start, timer on. If I say stop, timer off.
Okay po. Thank you.
Okay. John Lester, get ready for the to record.
Yes po, sir.
Okay. Okay pa, if I say start, time on.
Yes po.
Okay, trial muna tayo. Okay. Start. Stop.
1.89 po.
Okay, trial yun ha. Okay, we will get now, we start now the first trial. This will be repeated how many times? According to the table,
Materials po.
5 times?
Yes po.
Okay, 5 times. Okay. Start. Stop.
1.96 po.
I-record mo, John Lester. Okay. Trial 2. Start. Stop.
1.84.
Okay. Trial 3. Start. Stop.
1.88 po.
Okay. Trial 4. Start. Ay, mali. Mali.
Okay po.
Tumaya. Trial 4. Start. Stop.
1.96 po ulit.
Okay. Trial 5. Start. Stop.
1.90.
Okay. Those are the 5 trials.
Okay po.
So, you have to add this time trial 1 to trial 5 divided by 5. That will be the average time. So what is the average time, John Lester?
Wait lang po, sir.
One point? Ano ko mga average time, John Lester?
$1.91 po, sir.
1.91.
91.
Okay. Now we will get now the for the displacement or the distance the heavier mass descended, we have to measure two positions. So listen, okay. The initial position is when the two bodies are in equilibrium. That will be the initial position. Now, we have to choose a reference line. It can be the floor or the force frame dito sa top. Now, since you cannot see the floor, you can see the top portion of the force frame. We will use this as the reference line. Nakikita nito sa ilalim ng top of the force frame. Okay. So we have to measure the initial position. At the 0 centimeter mark here, 0, the initial position is 46. We will mark this as 8 sub 1. Okay. From this position, reference line, up to the level of the two masses, bottom portion of the two masses. That will be H1. Okay. And it is 46 centimeters. So you record that, leader, John Lester.
Yes
46.
po. Initial position.
Okay.
46 centimeters.
Now, the final position, when this is released, okay, the heavier mass will be at the lowest position and the lighter mass is stuck up on the pulley. So this the highest position of the lighter mass and the lowest position of the heavier mass. We have to measure also. So starting at the same reference line, okay, we will measure now the position, lowest position of the heavier mass. And it is 88 centimeters. So John Lester, 8 sub 2 is 88 centimeters.
Noted po.
Okay. So the displacement or the distance traveled by the heavier mass is the difference, H2 minus H1. And it is 88 minus, ano ba yung H1 na John Lester?
46 centimeter po. Bali, 42 po yung difference.
88 minus 46?
Opo.
O ilan yon?
42 po. Difference.
42, okay? So that will be 42 centimeters the distance the heavier mass has descended. Any question? May tanong ba kayo? Okay, we will go now to the second trial, additional 10 grams. Okay, we will attach the 10 grams on the one of the masses. Okay. So let us see what will be the time. So on the one of the masses, I attached already 10 additional grams. Okay, Paula, we will repeat the same procedure as we have done in trial 1. We have to measure it 5 times also.
Yes po, sir.
Okay, are you ready, Paula?
Yes po.
Okay, trial number 1. Start. Stop.
1.32.
Okay. Trial number 2. Start. Stop.
1.19 po.
Okay. Trial number 3. Start. Stop.
1.5. 1.05 pala, sorry.
1.05, okay?
Yes po.
Trial number 4. Sandali, natanggal. Okay, trial number 4. Start. Stop.
1.03.
And trial number 5. Start. Stop.
1.10.
1.10. So we have 5 trials. O
Yes
dyan,
po.
Master, you get the average.
1.138 po, sir. 1.138.
1 point.
138 po.
One 1.8 or what? Ano?
1.138 po. 138.
1.13.
Up.
O i-round na.
Bali, bali
1.
1.14 na po.
Okay, 1.14. Okay, since we use the same string and length, the displacement is the same as in trial number 1. 42 centimeters, 88 minus 46. Okay. So that is how to determine the time, average time, and the displacement of the distance the heavier mass descended. Do you have any question, class? May tanong ba kayo? We will go now to the table. Okay. Okay, doon, nakikita niyo ba itong table? Paula?
Yes po, sir.
Okay. So in trial 1, we use here additional 5 grams. On trial 2, we used additional 10 grams. Oh, what will be the mass of the heavier body? So this is trial 1, it is 20 plus 5. The trial 2, it is 20 plus 10. Mass of the lighter body, small m, 20 grams. So trial 1, 20 grams is trial 2. Okay. The height of fall or this is the displacement or the distance the heavier mass descended. Ito. And we found out that H2 is 88 centimeters and H1 is 46 ba yan? Yan na, sir?
Opo. Opo,
Okay.
sir.
So, ang sagot dito is 42.
2. Yes po. 42.
42 din dito. Okay. Average time, dito sa trial 1, ang sinabi kanina dyan, sir, is 1.91 ba yan?
Opo.
At dito naman is 1.4.
1.14 po.
1.14. Okay. So, yun ang mga data. So, we can get now the experimental value of the acceleration. The formula is A equals to S over T squared. Okay. So, ang S dito is 42 centimeters. T is 1.91 squared. Ayan, yan ang experimental value. Accepted value, the trial one, capital M is 25 minus 20 plus parenthesis, what will be the value of G that we will use here? Now, if you examine the units, CGS, system of units, centimeter, gram, second, system of units. So we will use here the value of G, that is 980 centimeters per second squared. Yan ang G. Do you understand, Paula and Jan Lester?
Ano po uli, sir?
Ano po yung G, sir? Can you repeat po?
Acceleration due to gravity.
9 point.
The CGS is 980 centimeters per second squared. Kasi CGS ang centimeter, gram, second, system of units ang ginamit nating units dito. Okay. So 980 centimeters per second squared to. Okay? Divided by M is 25 plus 20. This will be the accepted value of the acceleration. Ganon din dito sa kabila. This is additional 10 grams. So 1.14 seconds ang time. Average time. So A is equal to 2 times 1.14 seconds. No. 2 times 42 centimeters divided by 1.14 seconds squared. Ayan ang experimental value. Dito naman, same. You have to use this 980 centimeters per second squared. Okay? So, compute for the percent error of trial 1 and trial 2. Now, similar to what we have done in the experiment number 2, meron tayong data dito, draw the figure, kasunod figure ito, so that I will know what for trial number 1, additional 5 grams, and for trial number 2, additional 10 grams. So there must be respective figures for trial 1 and trial 2. So on those figures, you can apply the formula, algebraic sum of F equals MA. You will be computing the acceleration, andito naman, so that this, if you have the figure, it will be very easy to understand. Okay? So you have to compute the, you have to complete this table for the online activity that we have performed today. I also forwarded the data which is recorded during the, done during the face-to-face laboratory class. We performed this in the POP laboratory room in SEA. Okay. And the data that we obtain This is the data recorded during the face-to-face class on Newton's second law of motion. Okay. The data already given here, you have to solve for the experimental value of the acceleration, accepted value. Okay. Trial number 1 is additional 5 grams. Trial 2 is additional 10 grams. So you can get the experimental value EB and accepted value AB. Then compute the percentage error. This will be the formula. Percentage error is experimental value minus accepted value over accepted value times 100 per 100. That will be percentage in percentage error. Again, I would like to remind the class that there is no negative error. Walang negative percent error. So, in case your the result is a negative value, just get only the absolute value. Okay, andito naman yung EB is experimental and AB is accepted value. There. So you have to okay. In preparing the report, read the instructions. Do you have any question, leaders? Paula and John Lester, may tanong ba kayo?
None po, sir.
Sir, question po. Yung gagamitin po ba naming data is yung record ngayon or yung recorded niyo po nung face-to-face?
Yung anong data?
Yung ano po, yung sa time po. Average time of descent. Yung record po na data ngayon or yung recorded niyo po nung face-to-face?
Pareho ang data na gagamitin nyo. Yung online, yung ginawa natin, doon nyo i-reflect yung figure. Okay. Dito sa face-to-face data, use compute also for this. Get the percentage error, then compare. Compare nyo yung results sa face-to-face data doon sa online, yung activity data na ginawa natin ngayong araw.
Gagawin pa po namin ng report itong pag-compare.
Pareho. Kaya binigay ko itong result dito sa face-to-face noon, na pinarform natin noon, para may comparison kayo. Bakit? Kung alin ang mas accurate, face-to-face activity or online activity. So I would remind again the group members, help your leader arrange a correct report. Okay. There will be no more revision this time. Binigyan ko naman kayo ng example how to revise. If you have any question with this concern with the how to complete this table, read the instruction on the computation and analysis portion. Will guide you. Any question? Okay. Now we will have the attendance. Want to know who are those present on this activity. If I call your name, please activate your camera and say present.
Sir, kailan po pala deadline ng experiment?
So kailan ba yun? Mamaya pag-usapan natin yan, okay?
Okay po.
Francis Autor, okay, 10 minutes. In 10 minutes, mag-expire na session natin. Meron tayong another session after this. And until the time is 7:30 to 9 o'clock. Okay. Gabriel,
Present po, sir.
nasan si, okay, meron tayong session ng 9 o'clock, Gabriel.
Okay po.
Gabriel Bautista,
Present po, sir.
Ann Benis Biete, Aliana Kaakbay,
Present po.
Mikey Caroche, Gabriel Collado,
Present.
JP Del Moro,
Present, sir.
De La Cruz Paula,
Present po.
Para Estuconing,
Present po.
Jubal Idolsa,
Present po.
John Magat,
Sir, si Magat po, nag-attend po siya pero kailangan niya pong mag-leave kaagad kasi may work daw po siya.
okay. Prince Mapalo,
Ay sir, question ko lang po, makakasama pa rin po ba siya sa experiment today kung sakali?
dapat maki-join siya para malaman niya kung paano ginawa yun. They have to. Okay. Mapalo Friends, Miranda Jemuel,
Present po.
Morales Kelly Alejandra,
Present po.
Cerveza Tricia,
Present po.
Nubora Cindy,
Present po.
Roy Oli,
Present po.
Pangantihon Ivan, John Lester Prieto,
Present po, sir. Andito daw po si Pangantihan.
Recto Jocelyn,
Present po.
Charles Reed, wala si Charles, Christine Sampilo,
Present po.
and Mark Villasaran.
Present po.
Okay.
Sir, hello po.
Yes, Ivan.
Di po gumagana yung mic ko kanina, sir. Present po.
Pangantihon. Okay. Sino pa hindi natawag? So we have already performed the application of Newton's second law of motion. Do you have any question?
None, sir.
Okay, do you see the screen?
Opo.
Okay, as I have mentioned earlier, we have already performed the actual application of force and motion, which is Newton's second law of motion. Now, what we were able to prove here now, okay, for the class to understand, since the statement of of Newton's second law of motion, the unbalanced force acting on the object will cause the object or the body to accelerate or move in the direction of the force. So, in this figure now, they are initially balanced. Okay. So, one of the masses should be added with additional weights so that there will be motion. So, we added here at M2 5 or 10 additional grams. So, the object changes their position. The heavier mass went down here and the lighter mass goes up. Okay. Now, as I have mentioned earlier, they are both 20 grams here. They're balanced. And when we add 5 grams, the heavier mass went down or descended. So, according to Newton's second law of motion, the net force or the unbalanced force that it is referred there is the additional weight, that is 5 grams. That 5 grams is the force that actually moved the object. That is the algebraic sum of F, unbalanced force or net force. Yun ang sinasabi ng Newton's second law of motion. That 5 grams and 10 grams are the net force or the unbalanced force. Kaya tinawag na unbalanced because it cannot be stopped. The body M2 will move downward. And that is the net force. Okay. Do you have any question, class? May tanong ba kayo?
Sir, yun dun po pala sa experiment ng pag-compare ng face-to-face at saka online, gagawan pa po namin ng analysis report separately.
Yung online data?
Yung pag-compare po sa dalawa, sa F2F at saka online.
Oh, you have to compare the data which is more accurate.
Gagawan po ng analysis report.
The allowable percentage error is 10%. Okay.
Okay po.
So, i-compare nyo doon. Ngayon, bakit yung isa mataas, yung isa okay. So, think of a reason bakit ganun ang result.
Sa conclusion na lang po namin or gagawan pa po namin ng ibang paragraph. Sa conclusion na po namin isasama yung report or sa ibang paragraph po.
Isama na lang sa yung conclusion, isang report lang.
Okay.
It must be short. Huwag niyo nang masyadong pahabain. It must be direct to the point.
Okay po.
Okay, so I hope all members of the class that are present today and participated in this activity understood what is Newton's second law of motion now. Okay. So, meron pa bang question? You can also, to understand more, you can also prove this by making the first diagram. So matatapos na pala. Okay. Thank you class for attending this first session. See you at 9 a.m. session, the second session. Thank you class.
Thank you po.
Bye.
Okay.
Okay, class. You're back. It's already 9. 5. How many members online now? 15. Okay. So there is no concern or problem on the experiment that we performed this morning in the first session. Okay.
Sir, question po.
Ano yan? Hold on.
Yung ano lang po, yung deadline po nung submission.
Okay. We have, today is 16. We have one more meeting on the 20. The last day for of classes this month or this year is 20 of December. So wala na tayong ano. So this will be submitted before our first meeting on next year. Okay. Kailan ba ang first meeting natin next year? It should be submitted before that. Okay?
Okay po, sir. Noted po. Thank you po.
So you have enough time to organize the report. Anyway, you have already finished the theory, so there will be no reason why you will not answer the report correctly. So wala na ibang tanong. Wala.
Wala na po, sir. Thank you po.
Okay. Okay, we will perform the next experiment. That is application of statics, and the title is that is TORQUE. That is TORQUE. QUE. Okay, do you see the screen? Hello? Hello, Leslie? Oh, very good enough. Okay. Oh, I have to... So, kailan ka kailan ka mag-start? Ah, okay. Ayos yun.
Ang title,
Ha?
Head of Product Innovation,
Oh, hindi, maganda.
or Head of Innovation and Product Development.
As a section head of department head.
Parang head.
Okay. So, that's okay. Ngayon, kung may kaya sinabi ko, kung kailangan mo ng assistance ko dyan, sabi mo lang. Okay? So, good luck ka na, kaya ingat lang. Okay? Kaya mo yan.
Kaya ko lang.
Eh, ano mang, alam na ng company mo?
Di pa, sa January pa ako mag-resign.
Eh, paano kung opera ka rin ng gano'n? Yung
Kaya
mataas?
natin kung pera niya ako.
Impossible.
Ewan ko, baka operan din ako.
Mapipilayan siya.
Pero, naging mabait sa akin itong boss ko. Kaya, kahit na hindi ako bayad ng 2 weeks kasi nabayaran na ako before. But for 4 weeks notice ako.
Okay. Eh, kailangan ganyan. Kailangan isipin mo yung long-term plan.
Kaya,
Saan ka ngayon? Sa bahay?
sa work.
Ito. So, kumusta yung mga bata?
Ayun, sa school. Last day na nila ngayon.
Last day of classes nila ngayon. Okay. Kami sa 20 pa eh.
Kami, 22 pa nga.
Okay. Sige na, good luck. May online class ako. Okay, bye. Okay, we start. This is experiment number 4. The title is torque. The notation for torque is L. It is the measure of the tendency of the force to rotate an object. Okay. So, torque set. Okay. Objective of this activity is to study the concept of torque and the conditions that must be satisfied to attain rotational equilibrium. So this is the second condition of equilibrium, rotational equilibrium. Apparatus, the meter stick, the force frame, set of weights, weight hangers, holders, platform balance, spring balance. Okay. So these are the apparatus that we will be using today. Now, for the theory, we have already discussed the concept of torque. And to determine the torque, we have to understand the force and the moment arm. Okay. L is equal to F times F. Okay. Force is defined as the either push or pull acting on the object. And S is this moment arm, which is the perpendicular distance from the line of action of the force to the axis of rotation. Okay. Now here, since we are dealing with the second condition of equilibrium, the sum of the clockwise torques must be equal to the sum of the counterclockwise torque. Now in this experiment, we will be using the meter stick. So meter stick is an example of a uniform bar, and the concept of uniform bar, the center of gravity where the line passes, okay, is 1/2 of the length, the position of the center of gravity. So if this 1 meter, that is the meter stick, the center of gravity or point CG is at 50 centimeter mark. There. Now from the formula of torque, the rotational equilibrium or second condition of equilibrium is algebraic sum of L about the point of rotation equals 0. And here in this activity, we will use clockwise torques positive and counterclockwise torques negative. As I have mentioned before, algebraic sum of torque is perfectly arbitrary. So we can assume clockwise as positive, counterclockwise as negative. Or if you want clockwise negative, counterclockwise must be positive. So we're going to the procedure. For the procedure, and for every procedure, there is a corresponding setup. The procedure 1, this is the setup. Procedure 2, setup, and procedure 4 here, that is the corresponding setup. And the last, procedure 5, nakalagay naman dito, this is the figure. So, puro figure ito. Okay. Now, For every figure, there is a corresponding force diagram. Okay. Paano ko magagawa ng force diagram dito? Okay. As I have mentioned before, always drop vertical lines. Ganyan. Then, draw the horizontal solid line. So, this will be the force diagram. Ganon din dito. Okay. Vertical lines. Ayun. Then the force diagram under the figure. Also here. We have already covered that in the lecture. Okay. Okay, before we start this, I have to assign the next leaders on this experiment number 4. For group 1, the new leader is Jubel Idolsa. Jubel,
Sir?
you're the leader for group 1, experiment number 4, Jubel. Did you understand, Jubel?
Sir, na-assign na po ako sa ano, for
Ah.
activity 5.
Activity 5. Ay, okay. Nasa kabilang page pala. Okay. Activity 5 yung assignment mo, no? So, John Magat Lennon. John Lennon Magat. Nandito ba si John Lennon?
May work po siya.
May work. So, absent siya ngayon. Wala siya dito.
Wala po.
Itong si Prince Andre Mapalo. Wala rin.
Nandito po ako, sir.
Okay. Ikaw ang maging leader, Prince Andre, ha?
Okay po, sir.
4. Okay. Sa group 2 naman, 3-5 si Jocelyn Recto. Nandito ba si Charles Edson Ritt? Charles Edson? Wala. Absent si Charles.
Sir, andito po si Charles Edson.
Nandito pala. Wala ka bang microphone na Charles? Si Raya ang microphone. Ano ito? Okay, dapat okay yung microphone mo kasi okay, ayusin mo yung microphone mo next time ka magiging leader, okay? Instead, ang maging leader si Christine Sampilo.
Sir.
Present po, sir.
Yes.
Sir, ayos na po ata mic ko. Hello po, sir.
Dali lang ha. Okay na yung microphone mo, Charles?
Yes, sir. Yes, sir po. Okay na po siya.
Okay na pala. Okay, so, di ba, ikaw na lang, okay. Christine, next ka lang. Okay na pala yung microphone ni Charles Edson. So, ikaw ang leader, Charles.
Yes po.
Four, okay. So again, the leader of Group 1, Experiment 4 is Prince, Andre, and for Group 1, for Group 2, it will be Charles Edson. It's final, okay? Okay, we will start now. Okay, leaders, Prince Andre and Charles Edson, copy this table. Kopyahin yung table ito because you will be recording this the data. Okay. I already sent the copy of this procedure yesterday. So, nasa sa inyo na itong mga form na at table na ito. Are you ready, leaders?
Yes, sir. Ready po.
Prince, Andre, and Charles. Okay.
Yes, sir.
Okay, so mag-start na tayo. Okay, do you see the force frame and the meter stick? Nakikita niyo ba?
Yes, sir. Pero nasa gilid po ng slide. Ayan po.
Okay, okay, ganito yan. Okay. Okay, the procedure number 1. This is the force frame. This is the meter stick. Okay. Number 1, set up the apparatus and locate the center of gravity of the meter stick by adjusting the point of suspension until the meter stick is in equilibrium. So, we have to get the center of gravity, to determine the center of gravity of this meter stick. We have to suspend this meter stick from the force frame using a string. This is string. Okay. Now, as we have discussed in the theory, the center of gravity of the uniform bar is at the center or length divided by 2. So since the meter stick is 100 centimeter long, 100 divided by 2 is 50. So it should be at 50 centimeter mark. Let us prove if it is at 50 centimeter mark. We have to adjust the suspension of the meter stick. There. It is already balanced. It is at 50 centimeter mark. You write there, Prince and Charles, center of gravity of meter stick at 50 centimeter mark. Nirecord nyo ba?
Yes po.
Okay. Next. Number 2, at 10 centimeter mark of the meter stick, hang 40 grams. So here's the 10 centimeter mark. And locate the position at which the 80 gram must be hung to produce rotational equilibrium. Now, as you see, the meter stick is horizontal and it is already an equilibrium. So we have to hang 40 grams at 10 centimeter mark of the meter stick. So this is 40 grams. We put at 10 centimeter mark. And it will be balanced by 80 grams. So 40 grams is 190 volts battery. And 80 grams, of course, 2 batteries. Okay, the same size. So this will be balanced or hung at the other side. Okay. So we know already that the 40 grams is at 10 centimeter mark. So that we have to adjust the suspension of this 80 to make the meter stick balance. Okay. There. It must be balanced. There, it is already balanced. Okay. So on in this side, it's 10 centimeter at 10 centimeter mark. That is 40 grams. And the other side is at 70 centimeter mark. That is 80-gram mark. You record that, leader.
Yes, sir. Recorded po.
At 10 centimeter mark, 40 dito. Yung 80 at 70 centimeter mark, nandun yung 80. So the meter stick is at horizontal or equilibrium. So you record that, we will compute that later on. Okay. For the next procedure, after equilibrium has attained, convert the masses into force equivalent and the lever arm into meter. Record all torque producing forces and their respective lever arms. It is moment arm. Okay. Identify its torque as clockwise or counterclockwise. So this will be converted to force, the gram converted to force, and the moment arm will be converted to meters. So that the system of units you will use is MKS. Okay. Procedure number 4. Attach 2 weights on the meter stick at 10 centimeter mark, hang 20 grams, and at 20 centimeter mark, hang 10 grams. Balance their moments by 60-gram mass to be hung on the other side of the fulcrum. Repeat this procedure 3 and compute the percentage deviation. Okay? So we will now change the weights here on this side. Okay. First, at mauna muna yung sa 20 centimeter, that's 10 grams. Okay. So these 10 grams, we use small battery. And this is, ano ba ito? Okay, triple A battery. At 20 centimeter mark. And at 10 centimeter mark, we will put 20 grams. Okay. There. So this is 10 grams at 20 centimeter mark and 20 grams at 10 centimeter mark. It will be balanced by 60 grams on the other side. This is 60 grams. There. So maintaining the center of gravity, point of center of gravity at 50 centimeter mark, and 10 at 10 centimeter mark, we hang 20 grams. At 20 centimeter mark, we put 10 grams. So we will now adjust the suspension of this 60 grams to attain rotational equilibrium. See, okay, it is now balanced. See? Prince and Charles, you record this at a 10 centimeter mark, we put 20 grams. Okay. At 20 centimeter mark, we put 10 grams. Now, where will be the location of the 60 grams? It is at 66 centimeter mark. Did you record that, leaders?
Yes, sir. Recorded po.
Okay. Dito 66 66 dito sa 60 centimeter mark. Okay, that is procedure or setup number 4. On setup number 5, we will remove now this weight. Setup number 5 is slide the suspension of the meter stick as far as possible towards zero end of the meter stick. Record this position at the axis of rotation. With a loop of thread and spring balance, apply a force near the 100 centimeter end of the meter stick so that equilibrium is produced. Record the force exerted on the spring balance and the moment arm. From the loop moments, calculate the weight of the meter stick, then weigh the meter stick on the tripod beam balance and record relative deviation between the values. Okay. According to the procedure, instead of putting the string here, we will slide the suspension at 0 centimeter mark. Dito. Okay. There. So this will be the axis of rotation at 0. And at the end, other end of this meter stick, we will put the spring balance. Dito sa kabila, dito. Okay. So, we have to put first at the 0 centimeter mark. Okay. Okay, this is now the thread is tied at 0 centimeter mark here. So it will be attached There. Okay, do you see it is attached already at 0 centimeter mark? Nakikita
Yes,
niyo ba?
Opo.
Okay. You have to move the post frame. And on the other end, we will attach the spring balance. Okay. Okay, this is the spring balance. Okay. Okay, this is the spring balance. Before we attach this, we have to set the balance at 0 reading. Okay. Ito, may dapat iset muna sa 0 reading. And there is a 0 adjustment here. If you press down here, the pointer will move. Oh. So, setting this to 0. Pag sinat sa 0 ito, you have to adjust this. Yan. Magalaw yan. Okay? So, it must be at 0 reading. There, it is now at 0. Nakikita nyo ba yung sa 0 reading niya?
Yes, sir.
Okay. So we will attach this at the other end. Okay. So that we will get the reading on the spring scale. Now this meter stick should be horizontal. Okay. There. So it is now horizontal and we have to get the reading in the spring balance. Okay. The reading is 80 grams. Auditors, you record that reading in the spring balance is 80 grams.
Yes, sir.
Okay. So, as you see here, at 0 centimeter mark, okay, we suspend dimension of the string. This will be used as the axis of rotation. Now, at 50 centimeter mark, the weight is located or concentrated at 50 centimeter mark. And the other force on the spring balance reads 80 grams. 80. Of course, the meter stick is horizontal or balanced or in equilibrium. So those are the data that we recorded. Now next, we have to get the weight of the meter stick using the balance. Okay. In using the balance, we will use the scale. Gagamit tayo ng timbangan. Okay. And since we have no triple beam balance, we will use this we will use this scale. Okay. The weight scale is ranges from 0 to 1,000 grams or 1 kilogram. Now, how to get the weight of the meter stick using this scale? Set muna na 0. Okay. There, it is already set to 0. Ka-0 siya. So we will just put this meter stick on top. Ayan. So that is the weight of the meter stick using the triple beam balance. Ayun ang lalagay natin. And how many grams? Okay. Ilang grams ba ito? Didilim. It reads 100. 128 grams. Yun ang nilalagay nyo sa Prince Andre and Charles Edson. Yun ang weight sa triple beam balance equals 128 grams.
Yes, sir.
Okay? So ganito ang pagkuha ng weight direct from the scale. So we have already finished the gathering of the data. We will go now to the table. Okay, do you see the table, Prince Andre and Edson?
Yes po, visible po, sir.
Okay, ano yung nirecord nyo dito, Andre? Center of gravity of meter stick sa how many centimeter mark?
50 centimeter mark po.
50 dito, okay. O, sa setup number 2, ang ilalagay dito is 40 grams converted to kilogram. I-divide lang 1,000 because 1,000 grams equals 1 kilogram. So 40 grams divided by 1,000 is 0.04 kilograms. So ilagay niyo dito, 40 grams equivalent to 0.04 kilograms. Ano ang Newton ngayon? Since the unit here is kilogram, to get Newton, multiply it by 9.8 meters per second squared. Newton na yon. Okay? Anong moment arm? Or lever arm? Yung 40 grams na nakalagay sa 10 centimeter mark. And pag nakalagay dito sa 10 centimeter mark, using CG as the axis of rotation, okay, nasa 50, 10 minutes na lang, okay, please listen. Okay. So, kung 50 ito, ang moment arm niya is 40 centimeters. So, convert this to meter. Paano i-convert sa meter ito? 40 centimeters. It is just divide by 100. So it is 0.4 meter. Okay. So this will be the axis of rotation dito. So yung 80 centimeter, 80 grams naman, saan nakalagay, Andre?
Sa 70 centimeter mark po.
70 centimeter mark. So ilang centimeters from 50 to 70?
20 po.
20. Yun ang moment arm. So i-convert yan sa meter. So 20 centimeters divided by 100, 0.4 meter yan. 0.2 meter. Okay. I-convert din ito sa Newton. So divided by 1,000 times 9.8. Yun ang Newton. Okay. So ano ngayon ang force diagram dito? Okay. Graph vertical lines. Ayan. Then draw the solid line. So ilalagay ngayon dito yung mga forces. So ilang Newton ito? Kasi sa force diagram dapat Newton na ang nakalagay. So, kinonvert ng kilogram times na 9.8, yun ang Newton dito. Ganon din dito. I-convert sa Newton, sa force, yun din ilalagay pababa. Okay. Ano bang ibang forces? Dito, nasan yung weight ng meter stick? Nasa 50 centimeter mark. So, pababa, yun ang weight, W. Yung tension on the string, ayun, nakabitin siya. So, tension pataas. So, hindi force diagram or free body diagram, it is in equilibrium. Kasi may force pataas, mayroong tatlong force pababa. Now, be sure in the force diagram, Andre and Charles, sa force diagram, ang ilalagay nyo, Newton na. Okay. 40 grams yung Newton equivalent, 80 grams yung Newton equivalent. Ganun yun. Ganun ang pagkuha ng force and moment arm. Ganun din ang gagawin nyo sa susunod na setup. Draw the force diagram, get the moment arm, convert it to force in Newton and lever arm in meter. Dapat sa report ninyo may corresponding force diagram. Okay. Dito naman, gagawan din ng force diagram. Graph vertical lines. Okay. Merong weight dito, W. Ito naman, pataas. Yung reading ng spring balance, that is, anong reading dito, Andre? 83?
80 grams po.
Ha?
80 grams po.
80 grams. So, i-convert sa Newton din yon. Then, to get the weight of the meter stick, ang formula gagamitin nyo is algebraic sum of L at 0.0 equals 0. So that, if this is the axis rotation, clockwise positive, so weight multiplied by 0.5 meter minus, kasi counterclockwise yan. Yung reading dito in Newton, which is 80 grams converted to Newton, multiplied by 1 meter. Equals 0. So makukuha nyo yung value ng weight, W. That will be recorded doon sa weight using the spring balance. Dito nyo ilalagay. Ito. Ito in Newton. Yung weight in the beam balance, ang reading natin doon sa weigh scale is Anong reading natin nung tinimbang natin sa huli, Andre?
128 grams po.
128 grams. I-convert ito sa Newton. Okay. Paano may convert yung 128 grams? Divide by 1,000 multiplied by 9.8. Yun ang Newton. Now, paano makukuha ng percentage difference? Yung positive torque minus the negative torque multiplied by 100, yun ang percentage difference. Kunin lang ang difference ng dalawang ito, multiplied by 100. There is no negative percentage error. So pag naging negative ang sagot dito, get the absolute value multiplied by 100. Yun ang percentage error. Ganon din dito. Kunin ang difference nito times 100. Yan ang percentage error. Ganon din dito sa setup number 2, number 4, at 5. May tanong ba kayo, Andre and Charles?
Wala naman po ako.
Okay, so that is the how to treat this. Dito sa per setup, isa negative torque, yung counterclockwise. Ito naman, pag positive, clockwise siya. So, babala yung sagot dito, babala yung sagot dito. Get the difference multiplied by 100. Yan ang percentage difference. Okay, class? Okay, I'll get the attendance. Okay. Francis Otar. Gabriel Joy Bautista.
Present po, sir.
Andiete. Kakbay Aliana.
Present po.
Mikey Caroche. Gabriel Collado.
Present po.
JP Del Moro. Paula de la Cruz.
Present, sir.
Para Stoconing. Jubel Idolsa.
Present po.
Magat John Lennon. Mapalo Prince. Temuel Miranda.
Present, sir.
Eli Morales.
Present po.
Christian Herbesa.
Present po.
Nobora Cindy.
Present po.
Roy Oli.
Present po.
Ivan Pangantihon.
Present po.
Reto John Lester.
Present, sir.
Jocelyn Recto. Jocelyn.
Present po.
Charles Reed.
Present po.
Christine Sampilo.
Present po.
And Mark Villaseran.
Present po, sir.
Okay, thank you, class. Merry Christmas and Happy New Year in advance.
Thank you, sir.
Thank you, sir. Advance Merry Christmas po. Merry Christmas.